Okay, problem 3. Again, let's stick with what we think is the easiest thing to see here. And for me, cosine is going to be the easiest thing to see, because I can see a starting point here and an ending point here. And the other good thing about it is I have exact values on my x-axis where I can work out period and stuff like that. All right, first thing we want to do is the amplitude. Okay. This case, we can see very clearly that the amplitude has changed. It's not going to be 1. So what I do is I just find the total distance between the trough and the peak, and then I just find half of that since it's always going to be our center line value. So this is -1.5, and this is going to be 0.5, 1, 1.52, 2.5. So 2.5. So the total distance here, when we add this up, the absolute value is going to be a total distance of 4 units. But remember, we're always concerned when it comes to amplitude about that center line, and we can just see that it's 2 full units for the amplitude. So we're going to plug that in here for our amplitude first. Now, second thing we want to do is find the period so that we can use that for our period here and also for our frequency. Well, one of the cool things that we can look at here is we can see that this guy, we have easy values to read on the x-axis from the starting point to the end point, and it happens to be 2 pi. So the period is 2 pi, and we know that that formula, 2 pi over b, if we were to calculate this out, that gives me b times 2 pi equals 2 pi, and if I divide both sides by 2 pi, these cancel out, and b equals 1. So good news there. We don't have to worry about that for our phase shift. Okay. Our vertical slide. Did this thing shift? It obviously did. What you want to keep in mind, this is kind of like the last problem where I told you if this graph gets stretched or it gets compressed, it's going to change how the units themselves get shifted out, okay? So what I want to do here is illustrate that. If we shifted this by an amplitude of 2, that means that this thing, and I know this is really poorly done here, but I'm just trying to focus on our starting point and down here, we know that if we shifted the amplitude by 2, it would look like this. Sorry, if we change the amplitude by a factor of 2, it would start here, and then the trough would be down here, which means to shift it after the amplitude has already been taken into account, we would only have to shift it up 0.5 units. So you don't need a formula for this, but you do need to figure out the amplitude first, and this is the big reason I tell you do this first. It helps you see what the actual shift was. If you were thinking that it started down here, you got to keep in mind it's the original graph. You'd say, oh, well, that's 1.5 units shifted. But you got to keep in mind that the amplitude had already been changed and then the graph was shifted. So we know that our vertical slide is positive 0.5 up. All right. Now, the horizontal slide, was this thing phase shifted? I'm going to write it down. Obviously, we can see that it did not shift at all, but I still want you to see that tool that we brought up in the last problem. We said for our tool 4 that the units shifted equaled C over B. So our B here in this case is 1, and there are 0 units shifted. So we plug this into a little formula. You could still take this 1, multiply both sides by 1, and you would see that 0 equals C. In other words, it hasn't shifted. We can see that. I just wanted you to see the formula in action one more time as well. So we know we don't have to worry about this part at all. Okay. Our max and mins, let's go ahead and find those real quick. It should be pretty easy, especially since we found the amplitude. We know that this is 2.5, and we know this is negative 1.5, so we can plug those in. And to finish out our equation here, I'm just going to write this out because it never hurts to see the actual formula over and over again until you memorize it. I know I have an amplitude this time of 2, so I'm going to plug that in for A. I've got cosine. B refers to my period, and my period I already know is 1. It really hasn't been shifted. It takes 1 full wave cycle for 2 pi. So I can even leave the 1 out, which I intend to do. Now, we know there is no phase shift for C, so we're going to leave that alone. But we know it's been shifted up 0.5 units. So let's go to the calculator, plug this in, and see what we get. Okay, with problem 4 here, let's start again with what we see is being the most easily identified function. And this time I am going to go with sine because it looks like I have a nice perfect S here. Again, at the end, I'll show you the calculator and what the cosine version of that function is. Okay, first thing we always do is find our amplitude. So, in this case, it's our center line and the distance from that center line to the peak or the trough. In this case, it is 1, and we can plug this guy in here and be done with that. All right, next thing we want to figure out is what is the period? How long does it take to make 1 full wave cycle here? Well, we know these are marked out in intervals of pi over 2, so when I combine 2 of them, that gives me a distance of pi here. Going another 2, that gives me a distance of 2 pi, and 1 more gives me a distance of 3 pi. So that means my period is 3 pi. But I need to know what the frequency is too. So this is where we are going to use our little formula here and set it equal to 2 pi over b. And when we do our algebra here, that gives me b times 3 pi equals 2 pi. And when I divide both sides by 3 pi, that cancels here, and the pi's cancel, and that gives me b equals 2/3. So that's my frequency. Okay. Now, we need to see, do we have a vertical slide here? Do we have any kind of shift? And this graph is pretty nice because we know we don't. This starts at 0, 0, and it hasn't been brought up or down, so we could put 0 in for our vertical slide here. And same thing when it comes to phase shift. We're also in good shape here because we know that it hasn't been shifted over to the right, and it certainly hasn't been shifted to the left, so we can also put 0 in here. Last thing we need to figure out is the max and min values. So we can trace this and trace this guy. That is 1 and -1, just like a perfect normal sine of x function. And in fact, this is almost exactly like sine of x, except for the fact that it has a longer period. But we'll deal with that in a minute. Let's go ahead and plug in our max and min values, and all we got to do now is focus on writing our equation. So we know the amplitude's 1. I'm not even going to worry about that. I do know that it has a frequency of 2 over 3. So I'll plug that in, 2 over 3x. Now, we have no phase shift. I could put in that plus 0 there, but there's no real reason to do that. And I look at the fact, does it have a vertical shift? No, it doesn't. Again, I could put in that plus 0, but why even do it? So that gives me sine of 2/3 x should give me my graph. So what I'm going to do here is pull out the calculator and show you, and then I will also show you the cosine version of this graph. Okay, and to save time, I already plugged in the sine version, which is what we were working on. Sine of 2/3 x, we graph this, and we can compare our graphs. Everything is exactly where it should be compared to our original graph. So what I want to do now is just show you what the cosine version of this is. And if we use cosine, this will be cosine. The frequency is still the same. The only thing that really shifts is the vertical shift, and it only shifts over in that pi over 2 direction, either to the left or to the right. So we're going to have 2 over 3 for our frequency here. We're going to plug in our x. And in this case, we would have minus pi over 2. And the graphs coincide. Everything is exactly where it should be. We could even double check it again by simply turning this function off and graphing it. Still exactly the same thing. Again, go ahead and check out the relationships here between the values of minus pi half or plus pi half when it comes to the relationship between sine and cosine. But again, we're just kind of going with what do we see first that looks the easiest. Okay, we are going to move into problem 5 here. And with problem 5, we are going to, again, pick out what looks like the easiest thing for us to pick out, a sine or a cosine. And if you're looking at it like I am, you are probably seeing cosine here. So I'll start with that. Again, at the end of the problem, I'll show you the signed version of this graph. Okay, first thing we always want to do is pick out our amplitude. So step 1, what is the amplitude? Well, if we take this imaginary line that divides our peaks and troughs, we can see that there's a distance of 1 between each. There's a distance of 1/2 between each. So that is going to be our amplitude. Then the next thing we want to do is figure out our period. So we'll plug in our amplitude here, 1/2. Now our period is the time it takes for one complete rotation, or one complete wave. So that means that my period is pi over 2. Again, I can plug that in here, but I need to find my frequency, so I will set that equal to our formula here and calculate everything out. Wow, that is one nasty looking B. Okay, so cross multiply, that gives me B times pi equals 4 pi. Divide both sides by pi, they cancel out, and I am left with B equals 4. Our frequency is 4, which makes sense because we have 1, 2, 3, 4 full rotations of the wave in 2 pi interval here on the x-axis. Okay, so we've got that taken care of there. Now, what we want to figure out is there any kind of shift here, either vertically or horizontally? So let's start with the vertical phase shift. Now remember I told you, whenever you change the amplitude of the graph by either stretching it out or compressing it, as it has been in this case, that's going to change your shifts a bit. So what you want to do is kind of picture this out. If this were the original graph and it had already had an amplitude where it was or changed or compressed by a factor of 1/2, you would have something that looks like this. So once you start from this point after the amplitude has been adjusted, then you count what that vertical shift was. And in this case, the vertical shift would be down 2 units, so we can put that down here. Okay, only thing we need to do now is find out what our maximum and minimum values are, which are pretty easy to figure out. These are in increments of 0.5, that's -1, that's -1.5. So we can put that down for our maximum value, and our minimum value would be down another -1, so combine that there, and we get -2.5 for our minimum. And our phase shift, we don't have that here. Again, it's at a kind of a cosine starting point. It has not been shifted to the right or to the left. Now we can go ahead, and since we're focusing on the cosine function, we know that our amplitude is 1/2, so we are going to have to put that in this time. Cosine. Is there a frequency that we need to be aware of? Absolutely. The frequency here is 4, so we'll plug that in. Do we have a phase shift in either direction to the right or the left? No. So I'm just going to leave that out. And do I have a vertical shift? And we do. It's down 2 units. And that gives us our cosine version of this graph. So let me show that to you on the calculator, and then again I will show you the sine version of the graph that's just been shifted over plus or minus pi over 2. Okay, so I've gone ahead, I've already plugged this in. Matches what we've got down here, 1/2 cosine of 4x minus 2 on the outside, and if we graph this guy, we have everything we need to make it look exactly like the graph we were given. So what I want to do now is show you the sine version of this graph. So the only thing that changes is the phase shift. Everything else stays the same. It would still have an amplitude of 0.5. It would be a sine graph. It would still have a frequency of 4. The only thing that would be different this time around is that we would be shifting it to the left by a factor of pi over 2. And then we'd finally be shifting it down 2. And the graphs coincide. You can see they are 100% perfectly the same. Okay, problem 6. 2 more problems after this, and we are home free. All right, like always, let's start with what is it that is easiest for us to see, a sine or a cosine? Which one? Well, if you're looking at it like me, again, you're going to see a cosine in this one. So we're just going to go with this guy, and as always, I will show you the sine version at the end. Okay, let us go ahead, now that we've identified our cosine, and figure out what our amplitude is. Well, if we divide this thing in half and we trace it from peak to trough, we see that our amplitude is 1. So we can write that in and move on to our next point, which is the period. So let's see how long it takes for one complete one complete cycle of the wave. So this is a cosine, starting point to the end point. Well, that's a distance of pi. That's another distance of pi. So our period is 2 pi. So we can write this in here. And if we want to figure out our frequency, hopefully you know by this point it's simply 1 since it really hasn't changed, but we can still use the formula. Cross multiply, we have b times 2 pi equals 2 pi. Divide both sides by 2 pi, and b simply equals 1. Okay, now we need to take a look and see, do we have a vertical slide here? Well, that's pretty obvious by the graph. We know that this graph has actually, if it goes from its normal position, which is up here, this graph has been shifted down to really, let me redraw that and let me clean this up a little bit. If this is our original graph, up here, and again, it's not to scale, it's just to kind of compare the starting points, I can see that I have shifted down 1. So I am going to put that down here for my vertical slide. It is -1 in this case. Now, I want to compare and see, is there a horizontal shift? Well, again, if we just use this as a comparison, we could see that it has been shifted over pi units. And in this case, because we're going to the left, our phase shift would actually be positive pi. Now, why didn't I worry about whether this was kind of weird, like I needed to be careful about, did it really shift pi units or did it shift pi half or something like that? Because my amplitude was 1 and my period was also normal. My period was 2 pi, which the frequency was 1. In other words, this graph has not been compressed or stretched vertically, and it hasn't been compressed or stretched horizontally. So I didn't need to worry about any of those factors changing either the phase shift or the vertical slide. I could just go to town on that. It's when your amplitude changes and when your period changes that you need to kind of look at these things more closely. Okay, getting back into business here. We have a maximum value at 0 and a minimum value at -2. This leaves us with simply writing out our equation here. So, since I'm going with cosine, I know my amplitude's 1, so I'm not going to put anything in here. I am going to say, well, my frequency is 1, so I'm not going to worry about writing that 1 in here. And I know that we have experienced a phase shift over to the left, so I am going to put that in. Remember, our insiders always lie, so even though we're moving in the negative direction, it's still positive here. And we also had a vertical shift down 1 unit, so that would be -1. So let's go ahead and plug that into the calculator, and then I will also show you the sine version of this graph. Okay, so I have the cosine function here already plugged in. Cosine of x plus pi minus 1 on the outside. We graph this guy, and again, we get a picture-perfect match, so we know we're on the right track with cosine. Just to show you again for the sine, this time if I take sine, boy, I do that a lot. I think it's because I'm used to my old calculator, my TI-89. Okay, if I take sine and I plug in x, this time, if I increased it by pi halves to the original pi that we have here, what I would have is 3 pi over 2. And then again, we'd shift it down 1. Okay, hold on. I made a mistake on that. I figured that would happen at some point here. See what I did incorrectly here. Okay, sorry about that. Pause there. It looks like I just plugged it in wrong. The equations are exactly the same. I just did something wrong with my parentheses, but when we check it out here, the graphs coincide with one another, and they're both enabled here. So let's move on to problem 7. Okay, problem 7 is considerably more tricky. The reason problem 7 is a little trickier is because it has both a phase shift and it has an adjustment to the amplitude, which means figuring out what C and D are going to be is going to be a little trickier, or we could just use every single tool that we have in our tool chest. So let's get started first. Let's pick out what we are going to use. What I'm going to go with here is sine on this one, because I can see a clear point here to mark by and a clear point here to mark by. And that'll give me one full sine curve. So we'll start here. We'll put that in. First step is always amplitude. Now, finding the amplitude here, we're just going to have to read this a lot more carefully. It might even help to mark off our y-axis tick marks for every 1. So we know there's half a 1 in here, even though it's hidden by the graph. So that's a value of 1, 2, 3, 4, 5. So we know the maximum's at 5. We can even put that in right now. Doing the same down here, that gives me 1, 2, 3, 4. So that gives me -4 for my minimum. Okay. Remember, the amplitude is what we say, hey, if we took a line, and I'll make a straighter line than I've made before, and we try and figure out the distance between the peak and the trough, well, you could count them all out here, or you could say, well, if this is -4 and that's 5, that means there's a total distance of 9 between these two. And since we know it's only half of that total 9, 9 divided by 2 gives me 4.5 for my amplitude. So I'll write that in here. All right. So let me clean this up a bit. We know our amplitude is 4.5. All right. Now we want to see if there has been, well, actually, I'm getting ahead of myself. Let's do our period first. Okay. How long does it take for me to make one full cycle of this wave? Well, again, the scale hasn't changed. That's -pi2. This is pi over 2. So that means I've gone essentially pi distance total here for one full rotation of the wave. So I need to figure out my frequency. So we'll use our formula here, do our algebra. That gives me b times pi equals 2 pi. And if I divide both sides by pi, my frequency is 2. So we'll plug that in here for our frequency, and we know that our period is pi. Okay. Now here comes the more difficult parts. We need to make sure that we understand, since our graph has been adjusted for the amplitude has been stretched, so our graph has been stretched vertically, and it has been compressed horizontally. This is going to affect how our phase shift and our vertical slide come out here. So let's focus on the vertical slide first. We know the amplitude is 4.5. That means since this is a value of 5 on the y-axis, if I had my starting point down here and I had adjusted the amplitude before I shifted this thing up, that means I would have only shifted it up by a value of 0.5 and 0.5 only. Again, when you're looking at these verticals, start by having the amplitude adjusted first and then find out what the shift was. So my vertical slide is 0.5. Now, we've got to remember that fourth tool that I brought up earlier. And that fourth tool is the units moved on the graph as you see it written equals C over B. So let's clean this guy up a little bit here so we can proceed and see what we're actually talking about. I know that this is the starting point for a sine graph. So that means as I see this graph written, it has been moved over pi over 2 units. So I'll put that here, pi over 2. And I know that's equal to C. Well, we don't know what C is yet, but we do know what our frequency is. It's 2. Once I use, remember this is tool number 4 in our tool chest, once I have this set up, I can figure out accurately what the actual phase shift is. Okay, so we do our cross multiplication. That gives me 2 pi equals 2c. And if I divide both sides by 2, that tells me that c is equal to pi. And all we have to do now is figure out the sign. Well, since we've gone over to the left and insiders always lie, that's going to be positive pi. Now we can write out our equation. Again, the tricky things here are recognizing that the amplitude has been adjusted and that the frequency or the period has also been adjusted. It's been stretched and compressed, and basically that changes everything else. So let's write out the equation and we'll see what this looks like on the calculator. Okay, since we are using sine, I know my amplitude is 4.5 times sine. Our frequency is 2x. We have a phase shift of pi, even though it looks like pi half. Again, remember this tool here. And we know it's been adjusted vertically up by 0.5. Okay, again, I've got everything plugged in like we wrote it down, 4.5 sine of 2x plus pi plus 0.5. If we graph this out and compare it below, we have everything exactly as it was shown to us here. A maximum at 5, a minimum at -4, and all the intersections, phase shifts, and vertical shifts happen exactly the same way. So let's do the cosine version of this graph. Amplitude would stay the same. We'd have cosine. The frequency would also stay the same. The only thing that would be different is it would be pi halves less. And plus 0.5 for our vertical shift. And when we graph, the two graphs coincide. So again, both of these are activated. So again, explore the relationship if you want there between the shifts and the sine and cosine. Hopefully at this point you're starting to get it, and this is just kind of redundant. But let's go ahead and kill this problem and move on to our very last one. Okay, problem 8, hooray, it's our last one. The bad news is we have also saved the worst for last here. So instead of telling you why that's the case, let's just go ahead and work through this now, and you'll see why, but hopefully we can make some sense of that at the same time. I'm going to pick cosine here to work with, and here's why. I can take a look at this point here, and I can take a look at this point here, and I've got some very clear values. That's 0, that's 3 pi halves, and that will let me kind of figure out the rest of what's going on here. So by looking at those values, I can also see that I have half of a cosine graph here. All right, first step, as always, find the amplitude. So the amplitude, again, is found by simply having this imaginary line and then saying, okay, what's the distance between the peak or the trough? And in this case, it's 1/2. So we'll write that in here, 1/2. Now, remember I said when the graph gets shrunk or expanded vertically, this is going to change how the vertical slide turns out. So we'll get to that when we get there, but again, that's part of the bad news. It's like, okay, well, we've got this to deal with, so this is going to have to make us think a little harder when it comes to the next step. Okay, part 2, let's get our period. Again, I probably shouldn't have erased that, but we know that half of this cosine graph is essentially a distance of 3 pi radians. Sorry, 3 pi over 2 radians. Which means if we think about that logically, the other half also has to be 3 pi over 2 radians, which means my period, if I add those up, is 3 pi radians. So I can write that in here, but I also have to find my frequency. So we're going to set that equal to our little frequency formula here. We'll do the algebra. B times 3 pi equals 2 pi. Divide by both sides by 3 pi, and B gives me 2 over 3. So I'll go ahead and put that in. Again, it's important to keep in mind, because the frequency is not 1, that is also going to affect how the phase shift comes out over here. But we'll get to that point as well. While we're getting ready to do the nasty parts of this, let's just go ahead and do the maximum and minimum values and get those out of the way. We know the maximum value is at 1.5, and the minimum value is at 0.5. Okay, now let's go ahead and think about the vertical slide. Remember, the amplitude is going to affect this, so what we should do is let's start with the original graph. What would cosine look like if we hadn't done anything to it at all? And it would look something like this. Again, kind of ugly, but this is meant to illustrate the concept. This original cosine has an amplitude of 1, but we're not dealing with that right now. We're dealing with an amplitude of 1/2. So since the amplitude is 1/2, that's the same thing as shrinking it or compressing it by a factor of 1/2. And what it would end up looking like is something like this if we had shrunk it, or in other words, we had changed the amplitude from 1 to 1/2. The reason I'm doing this is a really good comparison. Again, it hasn't been shifted over to the side yet. We don't need to worry about that since all we're really focused on right now is the vertical part of the transition. Now that we have a cosine function whose amplitude is 1/2, we can compare it to where this cosine function ended up here. And what we see is that it's been shifted up a distance of 1. So we can plug that in here for our vertical slide, and that leaves us simply with figuring out what the phase shift is next. Okay, this leaves us with the phase shift. Now, the good thing about a video is you can always rewind it and look at it several times, and then, you know, it's not like being in a lecture class where you go, oh no, I just missed that point, and now you're behind for the rest of the class. If that vertical slide went a little too fast, rewind it, look at it 1 or 2 more times, and you'll kind of see how I arrived there by doing the original cosine, then doing this, and then finally shifting things up. The phase shift is a little bit uglier, and here's why. Let's get into it first, and then I'll show you how this really works out either way. Again, if I think of my cosine as being out here for the full graph, right? I look at this and I say to myself, well, we can use our tool chest here. I can say that I've got my units moved, and that's as it appears here, and we can also compare it to here, equals C over B. So I can look at this and say, well, I know my frequency is 2/3, so let's write that over here. C over 2/3 equals, and what are my units moved? Well, I can look at this and I can say the total units moved essentially, because if this had to go back here, would be the same as it is over here. It would be 3 pi halves. Same thing here. So I could say, okay, well, that's 3 pi halves. And since I know that, I can go ahead and calculate everything out. And instead of cross multiplying, the easier thing to do in this case is just to multiply both sides by 2 pi over 3. And that gives me 6 pi over 6 equals c. And if I simplify that, that means c is pi. So I could put in here for my phase shift pi. Now the question you might be asking yourself right now is, okay, well what's so hard about that? Well, the thing is, you got to think about the sign. Is this plus or is this negative? And you need to do that every single time you have to calculate this. The problem is, I could start here and shift it in the positive direction, and from the original sign. So let's draw out the original sign here, unshifted. Let's see if I can do this without butchering it too much. Okay, what I did is I just paused the video so I could draw this without wasting your time. Okay, what I did is I basically took this cosine wave with every other shift except the vertical shift to explain to you what's going on here. You could look at this and say, well, hang on a second. If I shift it from here to here, wouldn't that be the same thing as negative pi for my phase shift as far as the sign is concerned of it? And we would say, yeah, because if we shifted it from here, this would be brought over to here, and we'd have this guy going all over again. But another question you might ask yourself is, well, what if I took it and shifted it in this direction? Wouldn't I still be left with the same thing? And if you did, if you took this blue line here and you shifted it over by that same 3 pi over 2 amount, you'd have this. So now you're saying, well, is it positive pi? Here's the thing in this case, because cosine, the way this graph is shown, it doesn't matter. You could graph it with a plus pi or a minus pi. I don't want you to get too freaked out by that, okay? If you noticed that oddity about this in terms of the phase shift, that's the explanation behind it. I'll prove it to you on the calculator. And the good thing about a graphing calculator is you can always test this out on your own, which really is a good idea to do in any of these problems, even though I haven't stressed it until this point. But let's go ahead. I'm going to pause it. I'm going to set these up on the calculator so that I can show you that this phase shift, the sign won't matter at all here. Okay, I got a little ahead of myself because I didn't write the equation out down here, but I will here at the end. And I'm sure you're probably good enough at this point to do it, but let's go ahead and look at it at the calculator real quick. This is the equation I would have written if I chose a phase shift for a negative pi. What I'm going to do is I'm going to come down here and turn this one off. If you're looking at it, you'll see it's the exact same equation. The only thing that's different is I put a plus pi in here. Let's go ahead and graph the first equation. And you'll see that we've got exactly the same thing. Crosses where it needs to, has the maximums and minimums where it needs to be. So what that was is I said half of cosine of 2/3 x minus pi plus 1 for the vertical shift gave me the same graph. But if you were getting confused earlier and you went, well, it could go either way. It could go this way or it could shift this way. Again, because of the way this graph is laid out, it doesn't matter. In this particular case, it doesn't. I've got the same exact deal here, 0.5 cosine of 2/3 x. The only thing that's different is this plus pi. When I enable this, and I'm going to go ahead and leave this one enabled so you see that the graphs graph right on top of each other. They're superimposed. I get the same exact thing. So if you ran into that point where you said, oh my God, I did this, okay, this is too much, don't freak out. That's the wonderful thing about a graphing calculator too, is you can plug this in as much as you need to and test these things out, especially when you're doing something like this. It's a very, very good idea to do. And the last thing I'll do before I write the equation out is just show you the sign version of this function, which everything else is going to be the same with the exception of a pi halves difference in the vertical shift. That would be minus pi over 2 plus 1. Graph this out. See, everything superimposes. And in fact, if I wanted to, I could even take this graph here and add pi over 2 and get the same thing. We're not going to go ahead and worry about that right now. It's kind of redundant at this point. So let me go ahead and just for completion's sake, write out the equation. We know the amplitude is 1/2. We chose cosine in this case. We know our frequency is 2/3 x plus pi plus 1. Again, this could also be cosine of 2/3 x minus pi plus 1, and you already saw the sine version of this. So hopefully this was very helpful to you. This is much better than actually writing out a solutions key and trying to send it. I know you've got about an hour's worth of video here, maybe a little bit more, but I really hope this is helpful, and next time we meet, if you have any questions on this, ask me, and we'll make sure to patch in the holes.